I start the session. So, welcome to today's session, where a webinar. Apologies for the delay because, honestly speaking, I've never done Facebook Live on a desktop. I have done it on my cell phone, but there's always a first time. Though I've tried getting over this technical stuff 1 hour before the session, but I think that it wasn't enough. Anyways, so Uh, yep, yes, it seems my voice is loud and clear. That's nice. So, uh, in my previous live video, which was just a few minutes back, you could see that I was wearing a mask, and that's me in the picture. So, thanks, but no thanks to Corona, we all are used to our seeing ourselves with a mask, and I'm so used to it that I'm even wearing one at home. Anyways, so today's session is actually going to be about why engineers will love project management. Okay, this is slightly different topic because this is less technical, and it is talking about soft skills and so on. So moving ahead, let me introduce myself. My name is Amit Khandakar. I am a project management professional, a PMP, and definitely that tells you why I'm doing this workshop or this webinar. I'm a Cisco certified network administrator. I'm teaching at Qatar University and at the electrical engineering department of College of Engineering. I've been teaching for the past 12 years. Okay, gosh, that's a lot of years, I think. Okay, it's making me feel old now. Anyways, um, I have been into research topics such as machine learning, autonomous driving, obviously machine learning, so it has to be, it's most autonomous driving is the one that is very closely related to machine learning nowadays. But I've also done work at for solar PV performance, having stayed in the Gulf. I work with biomedical sensors, electronics, communication engineering, and engineering education. So I'm involved in teaching labs at Qatar University for electronics, sensors, and communication. So that's why you can see that I'm more inclined towards biomedical sensors, electronics, and obviously communication because electronics was actually in a lot of way is always was started to help communication. So that's how you see my research areas revolving around those part. I'm also really interested in engineering education, and this is why I really like to work with the professional activities committee, which is holding this webinar, and then a member of this committee because of my active involvement in engineering education. I have been a soft skill trainer for the past 10 years, and I'm a firm believer in soft skills for engineers. And that's why today's workshop or today's webinar. I'm an IEEE senior member, and I am currently the IEEE Qatar Section General Secretary. If you want to know more about my research work, you can definitely Google me out at Google Scholar, and you can see some of the work that I'm really interested in, and hopefully we can collaborate if you have any ideas. Recently, I've been involved in using X-ray images for abnormalities, medical abnormalities such as COVID-19, tuberculosis, TB, and pneumonia. So these are my recent work, very recent work. Okay, uh, I've done some workshops on project management at Canada, at USA, at Finland, Poland, Portugal, Greece, Serbia, and recently I did it in Norway. I did not include that picture. But I've also been involved in training corporate clients at Qatar. For example, I did workshop for Kaharman Qatar Petroleum under the continuing education department of Qatar University. Um, so you can see that I have I am a firm believer in soft skills. I am definitely, I think you will believe that I'm somewhat of a technical guy who believes in soft skill and have done a lot of workshops for engineers around the world. And what I can say as a summary is that engineers around the world love project management tools and techniques. They engineers really appreciate project management. And when I tell them about the tools and the techniques that are involved in it, they really appreciate it. Um, they really appreciate the project management, and because project management, when I tell them that project management is no longer a vague or a big vague field, it has a lot of science involved in it, and there is a lot of maths and reasoning and maths and reasoning involved in this huge field. Engineers are really interested because we engineers believe in maths everywhere, or science or reasoning in everywhere, right? So no longer it's like, okay, I did the project this way because I liked it. No, there is specific reasons or maths involved in the way things are done. So you can always reason why a project is in a way that it is. So this really fascinated me before, and also this fascinated engineers around the world. And then they said that, okay, so as long as I can put maths in it, I can put reasons in it, that means I can control it, I can improve it, and so on, right? It's like the feedback loop that we have. Whenever you can get a feedback from the output, you can always control and rectify and make it better. So once this is conveyed to engineers around the world, they really appreciate it, and I think so. I'm being a little partial now. I think they will appreciate it more than project management people, because engineers are really good with maths. Okay, so definitely they can do. Uh, if I can say, being partial, much better, but definitely not less than project managers or project management people, right? Um, So, having said that, there was a very recent, obviously I've been a firm believer of soft skills, and really I really appreciate that engineers having and developing their soft skills. Recently, there was a very good article which said that soft skills are no longer soft skills; they are essential skills. So they are required in engineers, and no longer something that can be that can be acquired. But this is very much required now. So once you see the benefits, or the things, useful things in in project management, and once you understand that soft skills is a requirement by engineers nowadays, why not have project management as a soft skill, the different parts of project management as a soft skill, and then make use of it. So definitely, if you do that, there are lots of benefits. For example, you can always command a higher pay. Project management has has various knowledge areas which talks about communication management, that will definitely increase your networking potential. It can also increase your teamwork spirit, because you know how to deal with people, and then take the best out of your team. It will help you to it will help you to manage your projects more efficiently. So these benefits are very clear now. uh, Having said about my background and why I like project management, and how I have seen people around the world project love project management, and how it is no longer it is currently considered as a very essential skill. Why do I think people will love project management? Is because I've already said it, because project management has a science, and it is as technical as any other engineering discipline. There is maths, protocols, analysis involved in this, which engineers are really good with. Engineers are really good with things which can be reasoned with, which can be controlled with some tweaks and so on, right? So that's why engineers will definitely love project management, and it's much more easier than what we deal with, right? Again, I'm being partial here, but this is from my experience. Mm, and the good news is you don't have to devise the whole science and develop it, research about it. There is definitely books and certifications available for which can help you in mastering these tools and techniques. One of them is PMBOK, which is Project Management Book of Knowledge, and the other one is a certification, PMP, which I am in, and which can also help you if you're really interested in it, right? So, how did project management enter in my life? So, I heard about it during my undergrad studies period, okay, which was long time back, 10, 12 years back. Yeah, that's long time back. I just realized it. Okay, anyways, um, I was really fascinated that project management is very broad, but there is a detailed science involved in it. Okay, there are tools and techniques that are involved in it. As I said, there are dedicated tools and techniques to ensure efficient management of project. There are numbers that I can use to tell how good my project is doing, and it's not like, okay, my project is doing really good, but I have numbers to tell you how good it is doing, and these numbers are not out of assumptions. These are actual numbers that can be calculated. So that was really interesting. Okay. Then, as I said, it involved a lot of critical thinking and mathematics. So I know the numbers, I know where the numbers coming from, I know how to increase them. So how to increase them? Let's think about that. So that things really fascinated me. I was said that engineering degree with the PMP certification is a lethal combination. I still believe it is. So definitely that motivated me as well. It took me 4 years after my graduation, undergrad, to convince. Okay, let's do it. We have heard about it. Why not give it a try and do some more learning about it, get certified, and so on. I did 3 times the certification in 6 months to get over the exam. Okay, obviously the first 2 times I did not go through because I think I was a little bit overconfident. Then the third try was a genuine, well prepared try, and then I definitely trained myself on it and worked it out. So that's how project management entered in my life. Okay, uh, how did project management help me till now? Project management or my PMP certification helped me definitely, because I'm sharing this wisdom with everybody in the world, and I'm gathering their feedback on how they think whatever I learned can be useful for them and they can use it and so on. So there was a knowledge sharing as well, more networking based on that. Other than that, it also helps me in a lot of grants that I work on, because in a lot of grants you need to specify how you think you can manage the project and control it in case there are some unexpected risks and so on, whenever there is risk or something. So how are you going to manage that? And these are all things I could write because of my knowledge in project management and PMP, right? Project management professional. So definitely it was really useful for me. And anybody else can definitely use it more, because I'm in the academic field, I made use of it in this way. But if someone is in the industry, definitely is going to be a lot of useful there, because then he can really increase the efficiency of the company he's working in, using the tools and techniques, and he can communicate with his boss in a much simpler way, rather than just telling him that, oh, we are on track, don't worry, we'll finish on time, don't worry, we are not overspending, and so on. No, you give him numbers. See, this is the number, this tells you that I know what I am telling you, and we'll finish on time. Oh, this is see, because of COVID-19, we will have to overspend, and this is the number that we have to overspend because of so and so. So these all things can be more effectively explained or easily explained to boss, to your superiors, with the knowledge of project management. So today's session is going to be only introducing to certain ITTOs. What do you mean by ITTOs? Is inputs, tools and techniques, and outputs. so that you get motivated to know more. Mind you, this whole sessions I take are actually for from 5 hours to 5 days. So definitely, you will be just getting uh, you know introductory ideas about the whole project management from here. Definitely, it has to be a long sessions, and definitely, if you need to, have more such sessions, you can communicate with the IEEE Region 8 Professional Activities Committee. Okay, definitely. I talked about PMBOK. So PMBOK is a project management book of knowledge. It's recognized globally, and you can refer to it after my presentation. Whatever I'm talking about today is actually from that PMBOK. What is a project? That's a very fundamental and million-dollar question, because you need to know what you're dealing with. Project is anything which is unique, which is temporary, and has a clear start and finish. This is the fundamental definition of a project. Just to make it a little bit more funny, I have a cartoon for you to tell you what it is. And once you know what is not a project, you will know what is a project. So if you can see here, the two people are talking about a project. Is your project in a good shape? The other one is like, apparently, we started 5 years ago and no one has stopped us yet. So that definitely, my friend, is not a project. A project should be, you should have clear idea about when you started the project and when you're supposed to finish. Um, these are some examples of project, though there can be millions and millions of it. Software upgrade for software upgrade can be a project. HR reshuffling can be a project. Uh, um, Conducting a research can be a project. So these are examples of project. As I said, there is a science of project management already there, so there is no need of reinventing it. So the project management or PM book says that there are five process groups of project management. They are initiate first you initiate a project, then you start planning for the project. This is the place where you have to be really careful and take care of the whole project management. Once you have a good plan of it, then you start executing it. Definitely, sometimes in the execution phase, you might have to change some planning, but you should document it that, okay, if I have some changes in my planning, what is the way? There should be a proper documentation of how the planning can be changed during the other phases of the project. The execution phase, which is when you're executing it, and this is the most expensive phase because all the monies, everything is spent over here. Then you have the monitoring and controlling phase, something that goes a little bit off track. How do you control that? How do you keep monitoring the status of your project so that this could be reported? And finally, you have to close the project. And once you close the project, definitely you will document how the project went, and how you did the whole project, and so on. What were the lessons learned from the project, so that this could be used as a case study for similar projects in the future, right? So you see, there's a proper science involved in it, right? And this makes sense. Projects have constraints. You have to make sure that your project is within some limitations. The limitations were previously known as budget, which is cost, time required, and the scope. The scope is what you are supposed to do in the project, the deliverable, right? The output, the final output of the project. And as you can see, they form a triangle. So you always want this area to be small, and if any one of them changes, the area of the triangle changes. So if your scope increases, definitely the area of the triangle will increase, right? Because the cost and time has to increase. If your cost increases, then the time has to increase, right? And so on. So this is the constraint, and we always try to control them so that this stays within this limit, right? Recently, PMBOK says that there are some other constraints in addition to these three fundamental ones, and they are: risk is a constraint, resources are a constraint, quality is a constraint. So so we always try to keep our project or keep them under control, so that the project is under control and we don't increase the area that is formed by constraints. Okay, so PM box says that there are 5 process groups that we discussed, and there are 10 knowledge areas, and each of them can will have certain processes. Okay, so there are around 49 processes divided among the process group and knowledge area. So knowledge area means scope management, time management, cost management, quality management, HR management, communication management, and so on, right? And at each stage of the project, you have certain processes in them. So there are 49 of them, and each process have inputs, outputs, and tools and techniques in them, right? Just to get you more motivated, we'll look at 2 of them which are really important, and then how math is involved in them, just to get you introduced. For example, we'll be looking at a process um, in time management, which is sequence activities, right? And develop schedule. So these 2 processes, we just go through them. And then definitely there is one more thing, which is control cost in cost management. So we just look at 3 of them. There are 49 of them, and each one of them is really, really interesting. Okay, and has a lot of math and reasoning and analysis that can be done in them. So this is ITTO for each process. There are inputs in the process. There are tools and techniques that use the inputs and then give you the output. Before we start, we need to look at one of the most important process, which is creating WBS, which is called as work breakdown structure. So it has some inputs. It has a tools. It will use the inputs and give you the output, which is a scope baseline, which defines the scope of your project. What does a WBS mean? WBS is something like this. It's like the main deliverable of your project divided into work packages that help you fulfill the deliverable, and then activities for that work packages. So this thing is useful. This is a WBS, and this thing is a hierarchical decomposition of the total scope of the work. It helps you visualize the whole project. It helps you. It is the foundation for planning, estimating, and project control. So this is really important, and this will be used in all other processes, right? Let's look at some process in time management. So we'll look at a sequence activities process, for example. So it has some inputs, it has some tools and techniques, and it gives you an output, which is the one that we'll look at, which is project schedule network diagram, which is how the activities are linked to each other. So that's the output, and we'll just look at an example. So let's look at the technique PDM. What is precedence diagramming method? So for example, this is a PDM, and what it does is it tells you how the activities are linked to each other. So an activity like finalize guest list has a predecessor and a successor. Successor is the one that comes after, and predecessor is the one before. There are different ways that activities can be linked to each other, and it's very it's known to us, okay, but we're just giving it names, and we are categorizing them. So it can be finish to start, where one activity has to finish for the other to start. That's an example. It can be finish to finish, where the the predecessor has to finish for the successor to finish. That's an example. It can be start to start, where the predecessor has to start for the successor to start. It can be start to finish, where the predecessor or the predecessor has to the completion of the successor activity depends upon the initiation of the predecessor activity. So these are some types of linking between activities. There's something else that can that will be that we'll be using just for the math that we'll be looking later on, and that's called leads and lags. For example, two activities have finished to start relationship with a lead of 3 days. What it means is an activity can this activity has to finish for this activity to start, because it's a finish to start relationship, but there is a lead of 3 days. That means even before 3 days of this activity finishing, this activity can start. So sometimes you can have activities that that even though they are finished to start, but they have some sort of lead. That means the predecessor doesn't have to completely finish for the successor to start. There can be activities which have lags, where what it means is even though it's a finish to start, that means this activity has to finish for this activity to start, but there is a lag of 3 days. That means you have to wait 3 days or three time units before this activity can start. Okay, this three can be days, time, hour, minute, etc. Okay, and all this have to be stated in the planning documents, right? What is the time unit that is being used? Okay, so definitely we know that lead helps in accelerated time. Lead allows activities to overlap. That means activities can happen in parallel. Lag is a waiting time, which is not always desirable, but sometimes can be. Lag move activities further apart. This is an example. So you can see that there are four activities between two milestones that are okay, and there are we have the duration of each activity. So we know that activity A has 20 days, activity B has 10 days, activity C has 5 days, activity D has 6 days. We know the relationship between them. So the question can be, what is the duration between these two milestones? So you need to finish activity A for activity B to start. So from this point to this point, it has to be uh, activity A is 10 days. You know what? I'll just give you 5 minutes to look at it, and then I give you the answer. Let's do that. Okay. So you go like activity A is 10 days. So I finish activity A 10 days, and activity B will start from the 10th day. Activity B and C has a finish to finish relationship. That means activity B and C can finish at the same time. In fact, activity B can finish 2 days before. So the finish time for activity B is the duration of activity A is 20 days, not 10 days. Activity B duration is 10 days, activity C duration is 5 days. So because activity C can finish activity C can finish 2 days before activity B. So even though the activity B takes 10 days, so this activity C takes 5 days, so it doesn't have to wait 10 days for this activity to finish. It can finish before finish before that. Means it can let the next activity start before that. So instead of 10 days, it can be 10 minus 2. So 20, that is for this activity. 10, which is for this activity. So 20 plus 10 minus 2 because of the lead, plus 3 because of the lag, and activity D takes 6 days. So that becomes 37. So once again, Activity A is 20 days, this is 10 days, this is 5 days, and this is 6 days. So 20 plus, both of them has to finish at the same time, so I can say max of 10 comma 5, because there's a lead of 2 days, because suppose this activity finishes 2 days before, then this activity can start. So I can say minus 2 plus 6 days, there's a lag of 3 days, plus 3 plus 6. So that's 20 plus 10 minus 2 plus 9. That's around 37. Okay, that's a very simple example. I'm sorry for my handwriting, but that's an example. Okay, definitely, as I said, you're just going to get introduced today. We can have more detailed session later on upon request, right? Okay, that's another way. Suppose an activity and the estimate is given, so we can draw the PDM based on that, right? Okay, so start to A takes 3 days, so start to A takes 3 days. Start to B takes 4 days, so that's another wire, that's another arrow going away from that, from start. A to C is 3 days, so A to C 3 days. B to C, it's a dummy link, that means there's no relation actually between them. B to E is 2 days, C to D is 2 days, C to E is 6 days, E to N is 5 days, and that's 2 days. So using this duration, we can know something which is called as critical path. We look at it. Critical path is the actual amount of time taken for a project to finish. And that this critical path technique can be seen in another process which is called as develop schedule. Definitely it has inputs and then tools and techniques and outputs. Let's look at an example. So this is PDM of a project. So as you can see, there are many ways, that there are many paths from start to end, right? So you can see that one of the ways is from A to B to C to G to end, or it can be from A to B to E to F to G to end, or it can be D H I end, or it can be D E F end, right? So there are various paths, and each path has duration based on the number. So the critical path is definitely the path that is the longest, because if in that path anything is delayed, then the whole project duration will be delayed. You see? So you as project engineers, what will happen is you will try to focus. For example, if this path is 4 plus 3 7 7 8 10, this is 10, the duration is 10. This one is 4 3 7 7 plus 6 is 13, 13 plus 2 is 15. This one is 5 4 9 9 plus 6 15 15 9 sorry 5 plus 4 9 9 plus 6 is 15, 15 plus 2 is 17. This one is 5 9 11. Definitely this is my critical path, which is this one, because this is the longest. So now that's my critical path. That means me as a project manager have to pay extra care, or should focus more on these areas: D, E, F, D, E, F, D, E, F, G. Sorry, I missed that out. It should be like this: 5 4 9 6. Yes. So that's my critical path. So I should focus more on these activities, and I should put extra resources there, so that I make sure that this never goes more than this 17. So now you know why certain activities are more crucial than others. And this can also help me as engineers to give make use of raw talent, because I know that an activity which is 10, which is very really raw, and which is out of the critical path. For example, A, B, and C are out of the critical path. So what I can do is I can try and experiment with it. I can give new engineers opportunities to work in these work packages, so that I can train them, and in the process explore new talent. Whereas in D, E, F, G, which are in my critical path, I need to put extra resources, and I need to make sure that I put my best experienced people in that track, right? So these kind of analysis are really easy to be done when you know the math behind how critical path is calculated from the project management knowledge. Okay, this is another example which I will not have time to go through, but we can get a lot of numbers like float. Uh, uh, this is I'm sorry. That's the duration. Sorry, that's these are duration. But I can get some numbers like float to know which is my critical path. For example, if I subtract these both, I have a float of 0. So that's a 0. So from this, 0, 0, 0, I know that this is my critical path. And this will give me the idea of what my project duration. Okay, there is definitely ways of coming up with these numbers, right? And that's the beauty of project management, and that's the math behind it, right? Uh, I will not have time to. Okay, now as I said, sometimes you need to tell your manager or your supervisor how well a project is doing, and you want to give him numbers, right? So that can be that these numbers can be looked from the determined budget work package. And what happens in that is it has some inputs, it has some tools and techniques, and it has the output. And what do I mean by that? Okay, so that's my cost baseline. That means how my cost is varying during the whole duration of the project. Okay, it's usually an S curve. And after having my cost baseline, I can use it to control the cost. Or to control the cost, that means to give some work performance information, which will look at some numbers that can tell me, that can be calculated, and that can tell me how well the project is doing, or whether we are doing good or not. These are the numbers that I was talking about: planned value, earned value, actual cost, budget at completion, cost variance, schedule variance, SPI, CPI, and so on. So let's look at these four numbers. Okay, I have an example here which tells me what was my project, how much did I complete it at certain point of time, and using these numbers I can calculate parameters like this. Cost variance giving a positive number is good, and as expected, cost variance is giving me an idea about the cost spent in the project. So if I have a positive number, that means I am getting more than what I am spending. Whereas if I have a negative number, that means it tells me that I'm getting less than what I'm spending. That means it's just giving you an idea that whether you're under budget or over budget. Similarly, for schedule variance, SV, having a negative number tells you that you are behind, you are finishing less than what you are actually supposed to finish. A positive number tells you that you have finished more than what you're supposed to finish. So similarly, there is cost performance indicator. So if this number is more than 1, that means you are getting more for what you're spending. If it is less than 1, it means you're getting less than what you're spending. Similarly, SPI is scheduled performance indicator. If it is more than 1, it tells you that you are getting more than what you have finished more than what you're supposed to finish. If it is less than 1, it tells you that you have finished less than what you're supposed to finish. The objective is we have numbers that can be shown in reports and that can show you how well the project is doing. So at the end, I'm towards the end now. So you have your scope baseline that tells you what are the scopes of your project. You have a cost baseline showing you how the project money is spent throughout the duration of the project. You have a schedule baseline that defines the schedule of the project. And once you have all of them, you know that how the project should be, and you can use them to control the project. Definitely, if any one of them increases, it affects everything else and ultimately the whole project. All right, I hope I could fulfill that's all actually in the time that we have. I could have gone more and more, given you more examples, but as I said, the most important idea for today's workshop or today's webinar was to give you an idea about how project management is really something that engineers can are really good at and can do really well. Let's so that's all. Let me see if I can come back on my camera. No, okay. I wanted to bid by. Anyways, uh, okay. If you find today's workshop useful and you want more of it, definitely